Question number 8. Two small spheres, each of mass 10 kg, are 8.0 meters apart and connected by a rod of negligible mass. This system rotates about an axis halfway along the rod and at right angles to it. The question is asking us, what is the moment of inertia of the system? This is another question under rigid body mechanics, and let's look at some key pointers we can pick from this question. So we are told that we have two small spheres here. Each of these spheres has the same mass. So sphere 1 has a mass of 10 kg and sphere 2 also has a mass of 10 kg. Now the distance from sphere 1 to sphere 2 is 8 meters, but mind you, the rotation is occurring halfway between the two masses. So let's use these key pointers we picked and get into our solution. So if we try to picture our rotation, it is going to look something like this. So mass 1 here, we are calling it M1, mass 2, M2. Note where our axis of rotation is. So that is our axis of rotation. What has been labeled L is the distance, or that is the radius of the circle. So from one mass to the axis of rotation is noted as L. From the other mass to the same axis of rotation is noted as L, because that is the whole distance from one point to the other, which we can call the diameter. So the distance L on the left hand side is the same as the distance L on the right hand side. So realize that the expression has been written here that L plus L is equal to 2L, which we can call R, and R here is standing for our distance from mass 1 to mass 2. I told you before that this question is also under rigid body mechanics, and what we are asked to find is the moment of inertia of the sphere. But you have to know first of all what moment of inertia is. Moment of inertia can be defined as the resistance of the sphere. In this case, you are looking at the sphere. So moment of inertia of the sphere can be defined as the resistance of the sphere to a change in its rotational motion. So mathematically, we can write our moment of inertia, which is given as I, to be noted as mass times L squared, where L is standing for our distance from the axis of rotation. So from the axis of rotation to where our mass is, what we are denoting as L. From the axis of rotation to where our mass is where we are denoting as L. So I is equal to M times L squared. Mind you, the unit for that is kilogram meter squared, and moment of inertia is a scalar quantity. So we applying this formula for moment of inertia to the question we have above, we can write that our moment of inertia is given as, for the first mass times the distance from that mass to the axis of rotation, which would give us M1 times L squared, plus the moment of inertia on the other side, which is the mass M2 times the distance from the axis of rotation to the second mass, which is L squared again. So they are the same L, and the mass are also the same. So we can write that our moment of inertia is given as 2 times the mass times the radius squared. All right, so plugging in our values, that should be I is equal to 2 times 10 times 4 squared. We are using 4. The distance from mass 1 to mass 2 is 8, but we are dividing it into 2, and that should give us 4. So our moment of inertia is given as 320 kilogram per meter squared. So let's switch back to our question and choose which one among the possible answers is correct. So looking through it, A is saying that 160, B 320, C 640, and D is saying 1280. So our correct answer from the solution we just did is 320 kilogram meter squared. It's kilogram meter squared, not kilogram per meter squared. Kilogram meter squared.